The neuromuscular system is used for control of movement. So this process up the top here shows that a stimulus causes a nerve impulse down the sensory neuron to the central nervous system, and the central nervous system contributes the brain. So that's where the conscious decision is made, and that then travels to a motor unit, which then causes a response in the muscle. In a motor neuron, you have this thing here, and different parts of it all contribute to different things. So you have the axon, which is this long cord-like structure, which carries the nerve impulse down it, and you also have these myelin sheath, which acts as an insulator. And between each myelin sheath, you have these nodes of Ranvier, and there are gaps which aren't insulated, that causes the impulse to effectively jump the myelin sheath as they depolarize, and this process is known as saltatory conduction. And as it travels down the motor neuron, that is known as a wave of depolarization, or also an action potential. And it's an action potential because it allows the nerve impulse to jump down the axon, and causes the impulse to then travel quicker to it across the motor neuron and then to the muscle it needs to travel to. Once it reaches the end of a motor neuron, it would reach a neuromuscular junction, and at this neuromuscular junction, the impulse builds up, and if there's a great enough impulse past the threshold, then it would cause chemicals to diffuse across the synapse into the muscle, and causing the muscle to contract. A motor unit is the motor neuron we were just talking about, and all the muscle fibers it controls. So each motor unit controls a set number of muscle fibers, and this varies. So you usually get larger motor units in larger muscle groups. So a quadriceps muscle, for example, a motor unit in there would contain hundreds of different muscle fibers per motor unit, whereas a much smaller muscle, like a muscle in the eye, that would only contain a handful of muscle fibers. It would only be connected to a handful of muscle fibers per motor unit. And also, each motor unit all contain the same type of muscle fibers. So you would have one motor unit containing either all slow oxidative muscle fibers, instead of a motor unit containing slow oxidative and fast glycolytic. That wouldn't be the case, as it only contains one type of muscle fiber. The all or none law, this shows that as the impulse down the motor neuron is greater, so as it passes the threshold it causes a full response at every single muscle fiber that motor unit is connected to. They will all contract. But if the impulse isn't above that threshold, or it's too weak, that means none of the muscle fibers would contract in that motor unit. And during exercise, during exercise, first the slow oxidative muscle fibers would be recruited, and then as the intensity increases, the fast oxidative glycolytic muscle fibers would then also be recruited, and then as the intensity increases even more, then the fast glycolytic muscle fibers will be recruited. So different motor units with different muscle fiber types would be recruited at different times, depending on the intensity of the exercise. Now, proprioceptors, they detect changes in muscle length. So the two main types are muscle spindle apparatus and Golgi tendon organs. And the muscle spindle apparatus, now this one is located in the belly of the muscle, and this detects stretch and the speed of stretch of the muscle movement. So and the Golgi tendon organs are proprioceptors in tendons, so they detect the tension. So if there's a pull on them, then they would cause a response to that. And a good example of this would be the knee-jerk test to test reflexes that most doctors do. So the hammer would be the stimulus, and this causes the Golgi tendon in the patella to stretch, which causes an increase in tension for that. But as that is stretched, that then pulls on the quadricep, causing that muscle to extend quickly. And because there's stretch on that muscle and a rapid speed of stretch, although it's not a lot of stretch, the muscle spindle inside the quadricep detects that stretch and causes the muscle, sends an impulse to the down and afferent neuron, which goes to the spinal cord, part of the central nervous system, and that rapidly, as it's a rapid response, as the body sees this as a danger, as it wants to try to protect the muscles, it will travel down the reflex arc, down efferent neurons, and causing the quadriceps to contract, and also the hamstrings, as it's the antagonistic pair, it will cause the hamstrings to relax to allow that movement of extension in the knee in this case. And that is known as the stretch reflex. During going back to specifically the neuromuscular system, of the control of movement, the Wingate test, you can see at the beginning of this Wingate test there's a sharp increase of intensity, so that is when the the body has responded to that stimulus of hearing the the go to start the test, and that's why there's a sharp increase as the body is then rapidly trying to produce power on the bike, as it is a maximal test. And then, as you can see, the performance then drops slightly as the body fatigues. But what's important is that sharp increase at the beginning to show the response the body has to that exercise. You also have kinesthesis, and this is using proprioceptors to, in a way, have a feel of what is good and what isn't in a sport. So, for example, here we've got a free throw in basketball, and as these are professionals, over time they'll be able to realise before the ball actually travels into the hoop or not, whether the ball will or not, to see if it's either a good throw or not, due to their movement and the feel of the movement, as they know it so well from muscle memory what a successful throw or not a successful throw is, that they will know through their proprioceptors whether it be a successful shot or not. And looking at a football header here, this uses the stretch shorten cycle of a muscle spindle, as the sudden stretch of that muscle spindle causes elastic energy, sort of. So as that sudden stretch of that muscle by sort of squatting down to prepare for that jump, that will cause a extension in the specifically the quadriceps, and flexion in the hamstrings, and that will cause tension in the muscles, and that rapid movement like that would then cause a great more power to be caused. That means that they can jump higher due to this. And this also links to plyometrics, as that rapid jumping, maximal jumping up and then jumping down with that constant contraction and relaxation of muscle groups, with the muscle spindle responding to these contraction relaxations to, first to protect the muscles from overstretch, but also to this can be used to assist performers during their sports.